All right, hello. Can all of you see my screen here? Okay. Yes. Okay. Cool. So welcome to the IEEE and Data Science Club presentation on machine learning in Python. So this is a collaborative event between IEEE, so the Institute of Electrical Engineers, and the Data Science Club here at NJIT. So, just to briefly introduce myself, my name is Carlos Marinon. I'm a junior majoring in electrical engineering. I am the IEEE IT specialist and webmaster officer, and I am currently a machine learning research assistant for Professor Abdallah Krisha in the NJIT EC department. So, specifically, my research pertains to understanding computer vision, image processing, and more importantly, different machine learning techniques like federated learning, which won't be covering today. We'll be covering basically the fundamentals of machine learning in Python and more of that, etc. So, Kajal Gupta is the president of the NJIT Data Science Club, and she wants to present this slide.
So, hi everyone, and first of all, I would like to thank each one of you for being here with us today because this event was for you. So, I am Kajal Gupta and I am currently serving as the president of Data Science Club. And to give you an overview of what a Data Science Club is, a data science, anything you can think of, any event, any activities related to a data science, that is what our club does. So, in past we have held various events where we introduce the topics of data science to our graduate people. Our club serves specifically to grad students, but we are trying our best to extend our events to undergrad as well. And this is our first step where we have collaborated with IEEE Club to bring this events introducing the fundamentals of machine learning and deep learning to you. So in future, if you want to see more such events, we would be happy to do any these events for you. Feel free to reach out to us, subscribe our mailing list, be our member, and be sure to join our Slack. So, and I hope you enjoyed today's event. Thank you so much. Bye.
Okay, so to add on about what Kajal said, so this is a collaborative event. So IEEE is collaborating with Data Science Club, and I'm also here just to point out that data science isn't strictly just for CS or statistics people or people that have those typical backgrounds. It is also spreading away. It is spreading to engineering as well. So engineering there's a lot of great purposes for engineering, and we'll get to that later on in the presentation. But overall, it's kind of just bridging that engineering and especially data science can work together and be applied. So to understand what is data science, so data science overall in its most basic terms is defined as obtaining insights, information, and really anything of value out of data. So overall, let's say that you're working for a company and they want to understand different trends on social media, etc., or trends in the financial world, etc., like that. And you're pretty much trying to provide insights, do calculations, understand trends, understand where there's a correlation, and apply that to either decisions or just understanding that there is those types of correlations overall. Um, so data science combines three different types of backgrounds: maths and statistics, computer science and IT, and basic domain knowledge, business knowledge, etc. So with computer science and mathematics, you combine and you create a subset of data science, which is called machine learning. And then from computer science and IT, and also with general business knowledge, you create software development. And then from business knowledge and math statistics, you create a field called traditional research. And they all combine together into one field called data science. So why is data science important? So the purpose of data scientists is to extract, pre-process, and analyze data, as I said before. So through this, companies can make better decisions. Various companies have their own requirements and use the data accordingly. So in the end, the goal of data scientists is to make businesses grow better, understand the market, the industry, and nowadays, data science is an ever-growing industry and field where companies now are looking to get their hands on. So if you have a data science degree, expect to be paid very handsomely for it because it is a very up-and-coming field. So data science applications. So there's obviously multiple data science applications, as I said before. So there's e-commerce, where you can see that application mainly in Amazon, Apple, or any other website or site that sells online goods, items. Manufacturing, so understanding that's where kind of engineering kind of plays through, understanding monitoring systems, automating manufacturing units, maintenance, scheduling, anomaly detection, etc. Financial industry, so banking, so you can do fraud detection, make sure that identity decrease the amount of identity theft occurring, credit risk modeling, and customer lifetime value, and predicting other financial metrics that can be done. Then we have here healthcare. So healthcare, you can do medical image analysis, drug discovery, and other applications so far, mainly regarding healthcare, understanding different, of course, with COVID-19 going around, obviously data science and machine learning are being applied more than ever just to understand about the behavior of COVID-19 and where it could potentially go. Transportation, obviously Tesla, they have their self-driving cars, enhanced driving experience, car monitoring system, enhancing the safety of passengers. And then we have here, obviously, financial industry, finance, customer segmentation, strategic decision-making, algorithmic trading, which is what you see most of these banks do, and stock trading as well, as you see on the stock market, and risk analytics regarding if it's worth it to invest in a loan, regarding whatever. So those are the types of data science applications that are out there. Again, here, just a interesting model, more about data science applications, data science in healthcare, e-commerce, understanding about data science could also be used in cloud computing and cloud distribution of information, as you can see in the bottom right-hand corner image, where you can get like the cloud, and then you have new global updates, local updates, and then essentially that bottom right image is actually a reflection of a new machine learning technique called federated learning, which is what I'm also researching in my research regarding with deep learning. But we can get to that later. If you have any questions regarding that, we can go to that later. So what is machine learning? So the machine learning is the studying of computer algorithms that improve automatically through experience or exposure to data. So essentially, you say you have a computer program that is set to learn from experience E with respect to some class of task T and a performance measure P. And if its performance at task T are as measured by P, it improves with experience E. So essentially, in general terms, it's essentially just a program that is supposed to learn from different trends or from data, essentially, apply data science, understand trends, understand correlations, etc., so that it can improve on its either performance on its task, whatever that task may be. We'll cover that in the next couple of slides, and then from there it analyzes its performance regarding if it's either accuracy or loss, which we will get to later slides. And from there, it will learn from its performance from the previous task and improve with its experience by doing those tasks overall. So machine learning. So machine learning is dissected into 3 types of learning. So the first one that I like to go over is supervised learning. So supervised learning is a type of learning technique where you are given all the data. So you are given all the labels, you are given all the outcome labels that you expect from this certain amount of data, and then from there you give your machine learning algorithm or program all the data that it requires and all the labels it has so that it can do its task properly. So supervised learning is essentially you're given all the data, you're given all the outcome labels that you have for that data, and you do your tasks accordingly. So supervised learning can be dissected into 2 different categories, classification and regression. So regression is as simple as it sounds. It's essentially regressing. So it's pretty much predicting continuous values. It's predicting continuous values, and that can be from advertising popularity prediction, weather forecasting, market forecasting, population growth prediction. So these values are predicted continuously, or the values that are predicted are continuous. And then classification is very different. It's essentially you pretty much predict what type of value, or a type of value in a sense where, let's say, you're given an image and you're supposed to predict what type of image it is, or you're given this amount of data and you're supposed to predict either if it's this type of data or this type of data, etc. From that. That is classification. So next we go to unsupervised learning. So unsupervised learning is a very interesting type of learning as well, because what's so different about it is that, unlike supervised learning, where you have the outcomes where you're provided the outcomes for feeding it to your program or computer algorithm, this doesn't have that. So you're given the data and only the data. You're not giving any outcomes. You're not doing anything like that. You're not doing any certain tasks. So mainly the role of unsupervised learning is to understand about um, mainly gaining insights from data and understanding more about where this applies really with data science, because this is actually the type of learning where it really applies to data science the most, because mainly it's just given data. You're not giving any tasks to really do. It means like you're not really supposed to do any predicting values. You're mainly just analyzing and understanding the data. So those are dissected to two types of methods. So dimensionality reduction. So essentially, dimensionality reduction is essentially where you're given, imagine you're given data. Let's say you're given 13 columns of data in a CSV file. And what you want to do is you want to be able to compress the amount of data that you can use to still gain insights, so that it's easier for your computer algorithm to make calculations and etc. So dimensional reduction, so let's say you have 13 different parameters that you're doing for a model, and you want to do that, you want to bring that dimension down to 8 parameters instead of 13. So that is essentially dimensional reduction. So examples of that: meaningful compression, structure discovery, feature elicitation, feature discovery as well, to understand different feature applications and apply that to the data. The next type of unsupervised learning is clustering. So clustering is understanding about how to categorize the type of values. So how do you take the data that you have and how you can split that up into different categories, essentially. So what you can do is essentially, for example, you're given data regarding business, and it's pretty much it's giving data on surveys. So from there, you're able to cluster the different types of people that answer the survey. So let's say it's a survey that says that people, like, they ask if you like oranges, you like apples, you like strawberries. So clustering essentially does is what it's trying to determine from the survey or survey response data, where you can categorize the different types of groups within the data. So in a sense, we're clustering the data. That's essentially what it does. You can cluster and categorize the different types of data within the data itself. Then finally, reinforcement learning. So reinforcement learning is also a very interesting type of learning technique as well, because reinforcement learning is actually it's given data in real time. What I mean by that is that when you're doing a task, it automatically gets feedback. And what reinforcement does is that once it gets feedback, it tries to learn and it tries to adapt the types, or it's trying to adapt its decision making based on the feedback that it got. So obviously, the perfect example is playing chess. So you play chess against a CPU or etc. like that, and what it does is, if you make a move on the board and then the AI makes a move, that's what it's trying to do. It's trying to understand what are the best moves to do and try to beat you. So that, and another great thing it's different about the rest of the unsupervised and supervised is that it is given automatic feedback and it is real time. It makes a decision in real time. So why is machine learning important? So machine learning is important for a couple of reasons. The reason why machine learning is important is, one, it provides, it's pretty much, you're applying data science, but you're applying it more of a programming and mathematical statistics environment. And from there you are actually you're doing a task, but it's not really about understanding the data. It's more about, yes, you have the data, what can you do with it, what insights can you do with it, what tasks can you do with it as well. um, so this can be applied obviously in the sense machine learning as well as data science can be applied in financial markets, financial industry, and robotics, AI, etc. So as you can see here again, manufacturing, healthcare, insurance, customer service, transportation, all can be applied with, or all can use or utilize machine learning as well. So machine learning as well as data science in itself are very heavily required skills by companies as of today, and maybe for the next couple of years. So so most common machine learning algorithms. So there's linear regression, of course, that is very self-explanatory. You're given data, how many dimensions that is, and what you're doing is you're trying to fit. So linear regression is actually mainly used for regression tasks within a supervised learning. So obviously you're supposed to predict continuous values. Logistic regression is uh, Logistic regression is actually it's not actually used for regression tasks. So it's actually used for classification, which is very surprising. Logistic regression is actually used for binary classification. And binary classification, as you can tell from that word or from that phrase, you have two tasks or you have two categories that you want to categorize from certain data points, and you do that accordingly. So obviously we have naive Bayes, we have support vector machine. Support vector machine is a type of machine learning algorithm where it determines a hyperplane in higher dimensional space that determines the decision boundaries between data points. And from there, when it's given data, it will determine if it crosses or it decides where on the hyperplane decides from where the decision boundaries are created from the hyperplane, what category or what value it should have. Neural networks. So that's a machine learning algorithm that's actually supposed to mimic so it's supposed to mimic human thinking. Essentially, that is the purpose of it. So neural networks it utilizes a different type of machine learning technique where you get neurons and you pass them through different kinds of layers, convolutional layers, dense layers, etc. We'll get to that later in deep learning, but that's more of a deep learning application more than anything. So tools for machine learning. So there are different types of Python libraries that you can use. NumPy, specifically, NumPy is a great Python library because it makes easier for you to do calculations over higher dimensional data or lower dimensional data. It just makes it easier to calculate for your program to do. Pandas is actually a data frame type of library where it makes it easier for you to understand the data. It's pretty much Microsoft Excel, in my opinion. It's Microsoft Excel for Python. And then scikit-learn is the actual machine learning library where you actually apply the different types of machine learning algorithms. So how do you execute machine learning essentially? So you have to determine first what type. Well, mainly we're going over supervised machine learning. So in a supervised machine learning problem, what are you trying to solve? Are you trying to solve a value that has continuous values, or is it a classification task? So once you determine what that is, you organize and you clean up your data, which is one of the most important part of data science and machine learning out of all of them. That is the number two. Step two is the most important. After you clean up and organize your data, you experiment and you choose the proper machine learning model, and then you determine how to fit the model, and we go over loss functions to determine how the model improves over time from the data. Then step four, you train your machine learning model on your data. And step five, predict on new data. And if the output is not satisfactory, you go back and proceed again to step three and you experiment again with your machine learning model. So I'm going to be providing a machine learning coding demonstration. I'm going to stop sharing my screen. I'm going to show you.
And Carlos, just a moment. And maybe before that, if anyone has any questions regarding any of the previous slides, please feel free to ask. This is the right time before we jump into demonstration.
Oh yeah, so yeah, feel free to ask any questions. Don't feel free to stop me at any time. I'm trying to make this as simple as possible for you, for all of you to understand, so that it's so that the concepts here are clear. So,
Carlos, I think you can move
yeah,
with the details.
yeah. Wait a moment. So okay, yeah, I'm gonna share my screen. Okay, so this is a machine learning demonstration. So as you can see here, this is just Python programming. So I'm going to explain this Python, the code in the Python notebook step by step, just for you to understand. So obviously in this first code block here, we import certain files that we want to get our data from, and import certain libraries like OS, so that's operating system. So that's pretty general within Python. Tar file. So our file is actually a TGZ. So we'll have to extract that. So our data is actually from a GitHub repo. So we're gonna have to use that library, urlib and urlib request. Same deal with tar file to extract data.
Carlos, sorry to stop you for a moment. Can you please zoom in? The text is very small.
Sorry guys. Better?
Yep, much better.
Okay.
Thank you.
Okay. So as I said before, the first code block is central Python libraries that you need just to extract the data. It's not really about applying the data science yet. So here we take the site for the GitHub repo and we pass that through an OS, the OS library to join and create a datasets, housing, and essentially create within the folder here the housing dataset. So fetch housing dataset from the URL, housing path, etc. Make a directory, housing path, etc. So this is mainly, these first three blocks of code is mainly just to extract the data. And then here we import pandas, which is what we discussed before earlier. Pandas is the data frame type library where it makes it easier to visualize your data on a tabular setting. So here we return a pandas read CSV file, which is essentially returns a pandas data frame. So here we fetch the housing data and we load it into a variable called housing, and housing itself is a data frame. So as you can see here, this is the data that we extracted. So before I continue on, so this data is actually a California housing district data from and over time, pretty much this data goes back a couple of years, but overall, it just explains about it just demonstrates and shows about the different types of housing statistics that there are within each district of California, mainly Southern California. As you can see here, we have different types of parameters. We have actual geographical data, longitude, latitude. We have numerical data, housing median age, total rooms within each district of California. So this is districts. This is not actual houses. Total bedrooms, population, households, median income, median house value, ocean proximity. So to understand more about our data, we have to understand what types of, in Python really, what type of data it is. So we take the data frame variable, which is housing here, and we add the .info parameter. And what it does is it provides the type of data or the D type of data on Python for each of the parameters. So as you can see here, every type of parameter here is a float, 64, but the final one is ocean proximity, and it's an object. So ocean proximity is actually, if I zoom out a little bit, you can see here it's actually a categorical attribute. So a categorical attribute is essentially a parameter or a feature that is not numerically defined. So it's given category instead of an actual number. So we'll go into that later. So obviously here, this perfectly represents what type of data it is, mainly numerical and obviously categorical attributes. So we want to actually kind of calculate the amount of categorical attributes that fit in the housing dataset. So From here, we count the amount of different types of data or different types of features within the feature mainly. So for ocean proximity, there is 5 different types. So there's less than an hour away from the ocean, inland, near the ocean, near bay, island. So that pretty much just describes how many type of data that we have here overall and what kind of different categories that the categorical attribute has. So next, we want to understand the actual numbers behind our data, so mathematically. So we do a housing.describe on our data set or data frame, and we pretty much, it provides us certain data, like certain statistical attributes like count, mean, standard deviation, the minimum, 25%, percentile, 50 percentile, 75 percentile, and max. So this is just gives you a general understanding and idea about what these values or what each parameter has overall in accordance with its values. And as you can see here, it doesn't portray the categorical attribute ocean proximity because it is not numerical. So to handle categorical attributes like you see over here with ocean proximity, there is an actual pandas function called getDummies. So getDummy variables, it essentially encodes or hot encodes the type of hot encodes the categorical attributes, so that instead of seeing the category, the text categories, you actually see numerical values. So as you can see here, ocean proximity, when its ocean proximity has 1, 1, 1, 1, and ocean proximity is less than an hour away, 0, 0, 0, in accordance with if that district is anywhere near the ocean regarding the ocean proximity categorical attribute. Okay. So to understand our data more, so we have here, a quick way to get a good feel of type of data we're dealing with is to plot a histogram for each numerical attribute. So a histogram essentially shows the number of instances on the vertical axis that have a given value range on the horizontal axis. So I did 50 bins. Obviously, as you can see here, it's divided into different categories. So 50 different categories of data, and it's able to show different distributions of that data overall. And obviously, you can neglect the ocean proximity ones, but mainly you can see housing median age, total rooms, median income, households, population, total bedrooms, and etc. And you're able to gain insights from understanding the different trends from these different histograms. But I have to note that with histograms, you have to know that choosing the bin value, as you can see in the parameter here, it is very tricky. Because if you change the bin values, let's say to 10, excuse me, my bad. So if you can change it to 10, you might have a different output. See? So here, it is very misleading. So when doing histogram, just let you know that it is very misleading, the data that you can get from each graph. So just letting you know that using histograms doesn't tell the entire story. Okay, so one of the main things that from this housing data set is we want to kind of divide the portion of samples based on income category. So what we want to do is essentially with the data that we have, we want to split it so that we understand because mainly income category is actually one of the biggest factors when determining mainly the objective that we're trying to do here, which I forgot to tell you, is we're trying to predict the housing median value. So if we go back up here, so we're trying to predict this value here, housing median house value for each district. So this is actually our labels, and everything else is the parameters. Okay, so this is the label that we're trying to predict, and everything else is the parameters that we're using to gain insights from and predict those values. But regarding data, so we're trying to understand about how we can dissect the data and understand about how we can divide the portion of samples or instances based on a different category, which is, in this case, income overall. And from there, we're creating we create a graph, and we take the median income column or parameter, and we essentially divide it into bins, and we label it so that we understand the different types of or how much overall the income is divided over different types of categories overall. So overall, we understand that we want to understand the data mainly with the income categories, but now we want to apply that to the test and training data. So what we try to do is we try to create a stratified shuffle split. So what that means is stratified sampling mainly is saying where, let's say that in your training data or in your overall data, you have, let's say you say that 50% of the data or this percentage of data is reflective from the overall data set. So what you want to do is that since it's 50%, it reflects 50% or whatever percentage it has. You want to reflect that when you divide it into the train and test sets. So let's say that let's say 50% of people like strawberries. So what you can do is a stratified shuffle split essentially does is that when you divide your train and test data sets, it makes sure that the train and test have 50% of the inputs are people that like strawberries. So it tries to keep that ratio from the data and tries to mimic that in the train and test sets. So as you can see here, we have the stratified train set, and you can see here with a hot encoding, we're able to see essentially the same values we saw from the housing data set. Nothing really changes, but but you can see what's different is that we have these values. So we have instead of the traditional, how many values do we have here? We have 20,640 rows. So that's 20,640 instances of data. And then here in the stratified, we have 16,512 rows or 16,512 instances of data with 15 columns. So essentially, we're dividing and we're creating our train sets overall. Same with the test sets. Instead of the actual value for the housing data set, we have 4,128, which is essentially just reflecting what we will be doing on our test data. So so we want to understand what are the actual ratios within for the categories for each specifically the stratified test set and the stratified training set. So we want to keep these ratios the same for each data set than when we split it. So like I said before, so we see that 35% of people or 35% of the data are categorized into the third category of income category or in the third type of income category. So that means that when we split it up into the test and train sets, it still has that same ratio of data. Same thing with the second type of income category has 31%. So 31% of that data, that's from the overall data, is still mimicked in ratio-wise regarding the test and train sets. So here we just we remove the income category attribute because we don't really need it anymore since we stratified the data set. And essentially, just to understand and explore data analytics, we just copy the strat train set at this point. So to understand beyond what we can do with the data, since we have geographical data, it's might as well we can plot it just to understand about how it works. So as you can see here, we're plotting a scatter plot, and the x values is the longitude, the y value is the latitude, and as you can perfectly see here, it looks like California, the southern part of California. And it just plots out, obviously, the locations on a graph, the different districts that are applied within this data set. So now that we know that it looks like California, we want to see a particular pattern. So what we can do is that we can set the alpha option or alpha parameter within the housing plot to determine the high density points. So housing plot, we make the same plot, we make a scatter plot, longitude, latitude, and alpha 0.1, so that we can understand the different districts that have the highest density in income categories, and overall housing median value. And then with an improved graph, you can visualize each data point with size and color attributes, which indicates the district's population and district housing prices. So we will use a predefined color option CMAP called JET, which ranges from blue, low values, to red, high values. So this image tells us that housing prices are very much related to the location close to the ocean and to the population density, as you probably know already. So as you can see here, it looks like California, but now it's more specific. It's gives you actual data points where you see that the median housing value, where it's red, is very high in comparison to most of the eastern part of California, where it's blue, where that has a low median housing value and overall. So this is essentially data analytics. You're gaining insights from data, understanding from this data set overall about understanding where the trends are and understanding about where you can potentially apply it. So correlation matrix. So since the data set is not too large, you can easily compute standard correlation coefficient, which is Pearson's R, between every pair of attributes using the correlation method. So this correlation coefficient ranges from -1 to 1. When it is close to 1, it means that there is a strong positive correlation. When it is close to -1, it means that there is a negative correlation. Note that correlation coefficient only measures linear correlations. This means that it does not take nonlinear relationships into account. So I do have to make sure you understand that this measures only linear correlations. So this does not take any nonlinear relationships into account when understanding and analyzing the data. So as you can see here, median housing value perfectly correlates with median housing value, which is obviously when you correlate something with itself, it's 1. And then the next best thing is positive correlation between housing median income with median house value. So that has a correlation of 0.68. The ocean proximity less than 1, 0.259. So obviously, where people have or people where they're less than 1 hour away from the ocean, they have a higher median house value, which is expected. Near the bay, same deal. Ocean proximity near the ocean, same effect where it is positive. Total rooms, and then as you can see, you can go down to bottom. So mainly, obviously, longitude and latitude have really mainly you can't really gain a correlation between that because those are coordinate points. But overall, the biggest thing to notice is ocean proximity inland. So that means that the more inland you are in California, the lower the median house value you will have for your district. So these are just types of examples where you can apply correlation matrix and overall with your data to understand obviously linear correlations and linear trends. So another way to check for correlation between attributes is to use the Panda scatter matrix function, which plots every numerical attribute against each other. Since there are now 11 numerical, we would like to get, obviously, we would get 11 squared plots, which would not fit on the page. So let's just focus on the few promising attributes that seem correlated with the median housing value. So we have median housing value, median income, total rooms, and housing median age. So what we do here is we plot each attribute against each other to understand the correlation. And as you can see here for most of these plots, mainly like this one, or let's say, yeah. So median house value, and median income, there's a positive correlation, as you can see here or also as well from the correlation matrix. From median income, so again, positive. And mainly everything else is just a plot of data points. But as you can see here, there's these histograms. And the reason why there's these histograms is because when you plot an attribute against itself, it's essentially itself. So instead, Pandas actually creates a histogram that's standard for when utilizing this function. Okay, so mainly the most promising attribute to predict them using median house value is the median income. So let's zoom in on their correlation scatter plot. So this plot reveals a few things. First, correlation is indeed strong. You can clearly see the upward trend, and the points are not too dispersed. Second, the price cap that we noticed earlier is clearly visible as a horizontal line at $500,000. But this plot reveals other less obvious straight lines. A horizontal line around 450,000, another around 350,000, perhaps one around 280,000, and a few more below that. So you just understand the positive correlation between median income and median housing value. And the reason why it caps at 500,000 is because that is the cap that the data has. So it doesn't go beyond 500,000, but if it did, you would still see that it would still have a positive correlation overall. So in addition to that, you can experiment with attribute combinations and kind of visualize that overall. So before preparing your data for the machine learning algorithm is to try out various attribute combinations. So for example, the total number of rooms in a district is not very useful if you don't know how many households there are. So what you really want is the number of rooms per household. Similarly, the total number of bedrooms by itself is not very useful, so you probably want to compare it to the number of rooms. The population per household also seems like an interesting attribute combination to look at. So let's create these new attributes. So within the housing data set, or with the housing data set, we can test with these different attributes, attribute combinations, and essentially this is actually an example of dimensionality reduction, which I discussed earlier with unsupervised learning. So obviously in the sense where instead of just using housing or the total rooms in the households, you can actually dissect that and make it rooms per household for one attribute, or you can do total bedrooms divided by the total housing total rooms, which makes it one attribute, so you don't have to use total bedrooms and total rooms anymore. And then the same thing with population per household, so population and households. So obviously, again, this is my mistake. I kind of just recreated the code again for the correlation matrix just to understand the different types of positive or negative correlations, linear correlations overall with the median housing value. So preparing the data for machine learning algorithms. So instead of doing this manually, you should write functions for this purpose for several reasons. This will allow you to reproduce these transformations easily on daily data sets. You'll gradually build a library of transformation functions that you can reuse in future projects. You can use these functions in your live system to transform the new data before feeding into algorithms. So this is just a note that you can do this, but overall, just for the sake of this explanation or an example, I did not really do this. But overall, from here, I am declaring my label sets, which is the median housing value column in the housing the Strat trained data set. And then what I do is I drop that column, so that is essentially what I want. Same thing with the housing with the test data set. I make that the labels I want for the data, and then finally I drop it so that we can use that for prediction. So data cleaning. So this is actually a very important part for executing machine learning overall. So most machine learning algorithms cannot work with missing features. So let's create a few functions to take care of them. So we saw earlier that the total bedrooms attribute has some missing values. So let's fix it. You have three options. So first option is get rid of with corresponding districts that have missing values. I am very against this. Do not do this unless you really have to. Getting rid of data is very bad because it makes it typically harder for your model to do better and generalize better for values. Get rid of the whole attribute. Definitely against that as well, that you don't really have to do that unless you're forced to regarding your data. So no, options 1 and 2, bad ideas unless you actually have to do it. But mainly step 3 is the one that you go to overall. So you set the values to some value, 0, the mean, the median, and etc. So an example of step 1 would be dropping the subset or the column total bedrooms, which I don't recommend. Option 2, you drop the parameter overall. Don't recommend that either. Option 3, so you set the values to some value, either 0, the mean, the median, of the entire column set. So obviously from here we have median, and it equals housing total bedrooms dot median, and we get the median from that category overall or from that parameter, and then we fill the options, or we fill the data points where it has not applicable, and we replace it with the median so that we can apply that and we can use it for our training data. So because I have to remind that when getting data, you have to understand that data, it's very difficult to get perfect data. And what I mean by perfect data is that perfect data, it comes with everything. It comes with everything. So in the real world, you can never do that. There's no option, or there's nothing like that ever overall that the data is given to you straight up front. So you pretty much, the data analysis and the data gathering are mainly the main priority. And overall, what you want to do with the data is mainly up to you as a data scientist or machine learning engineer, etc., for you to do. But overall, that is why you have to do these data cleanup, because in the sense where sometimes you might have missing data for certain instances, and you'll have to do it accordingly. So again, just demonstrate that this is a data frame. It demonstrates like in a typical Excel type output where it shows the different types of parameters that we're going to be using. And then here we go into the actual machine learning part. So obviously it took a while for us to get there, but probably the most important part is cleaning up the data and gathering insights from the data. But now that we're here, we take sklearn.linear model. So sklearn or scikit-learn has a linear model library and has a linear regression algorithm. So we take the linear regression algorithm, and we apply the option 3 here, the data cleaning option 3, set some of the values within the total bedrooms to the median of the overall data. And then from there, it trains over the data. As you can see here, we declare it. It's a linear regression, and then we train it, and has Strat. We train on the data that we have, so which is the Strat trained set, which is here, and the housing training labels, which we declared earlier, and it trains over it. Then here we do the option 3 data cleaning on the test set, so that we can predict it on the test set. And as you can see here on the third line in this block, we do predict on the Strat test set, and we try to understand overall from the predictions. So one of the biggest predictions that you'll get for using linear regression mainly is mean squared error. So mean squared error is a type of a loss function essentially that pretty much that you use for specifically or mainly linear regression algorithms, because it is able to calculate mainly the standard deviation overall over the entire data set and create a linear correlated model that makes it easier for you to predict housing test values. So as you can see here from sklearn metrics, mean squared error, R2 score. So we have the mean squared error. So read mean squared error, we use that, we apply that with the test labels and the housing predictions we have. And then the main metric that's mainly used is actually not mean squared error, because it's root mean squared error, because mean squared error sometimes has a high value. So we want to actually make it easier to correlate that overall with the data. And from there, we get our error or loss function overall, which is 67,343. So overall, this reflects loss. So what I mean by loss is that when predicting values, it compares the predicted values with the actual values that it's given overall for the predicted data, and it compares how much deviated the predicted value is from the actual real values. And the lower the loss, the better, which means that the lower the loss, the better overall. It's the model, because that since the loss is lower, it shows that the model is able to predict better with the data that you give it. And overall, obviously, you can see here that we still do have a high loss, but regardless or not, that comes from the amount of data we have. Even though we have 20,000 instances of data, that doesn't mean that we're going to have a perfect correlation or a perfect model overall, because there's no such thing as a perfect model, and there's no such thing as perfect data either. But overall, it's just the process of just trying to optimize the models, gain insights as well, and apply that. So yeah, that's our machine learning demonstration. I'm going to go back to the slides. Okay. So let's see. Okay. So now we're going to be going on to deep learning. So deep learning is a specific type of machine learning. So deep learning is a part of a broader family of machine learning methods and based on artificial neural networks with representation learning. So learning can either be supervised, semi-supervised, or unsupervised, like I talked before with machine learning types, supervised learning, unsupervised, and reinforcement. So deep learning is essentially the same, but you mainly apply artificial neural networks, which we will get to in the next couple slides. So why is deep learning important? Why is deep learning the main thing today? So the main reason why is because its ability to process large numbers of features makes it very powerful when dealing with unstructured data. And we'll explain that later with an example. But however, deep learning can be an overkill for less complex problems. So it is essential that the problem that you apply it to is complex. So what I mean by that is, like, say you want to do an artificial neural network that does a linear prediction output, or you wanted to do a linear regression output. The problem with that is that deep learning is mainly for complex learning. So it's mainly done for data sets that have higher dimensional data. So mainly like in the 3 dimensions or more. But overall, that is why deep learning is mainly used for computer vision, image processing, and etc. So it is essential that you apply deep learning to where deep learning is actually needed. So don't use deep learning for anything that you can use machine learning algorithms for, like linear regression, logistic regression, naive Bayes, or support vector machine, and etc. So the difference between deep learning and machine learning. So machine learning is you're given an input, you have to do the feature extraction yourself, you do the classification or regression output, or classification regression training, model training, and then you get your output. So deep learning is very different because in the sense where you get your input and then it does the feature extraction and classification for you, which makes it easier. So that's why deep learning is such a great tool, because in a sense it simplifies the feature extraction, it does the feature extraction for you, and it essentially simplifies that part of machine learning overall, and it gives you the outputs. So there are different types of, there's multiple deep learning concepts that you have to know before understanding what deep learning, the applications of deep learning. So neurons. So neurons essentially, like as you can see here, these blue single dots, those represent neurons. So essentially, just think of like your brain, and essentially you're inputting your brain data. So and within that data, everything is represented by a single neuron. So it has a single value. And then from there, you're able to represent the data in simpler form with these neurons, and you're able to kind of connect these neurons, which is essentially called layers. So essentially, as you can see here, as you cascade different amounts of neurons together into a vertical line here, or essentially called layers, you can essentially be able to do more analysis and computations regarding each parameter with itself, so that you can get more insights from the data. So as you can see here, you have an example, you have a neuron here. You have a neuron that you get an input of X, and then from the neuron, you actually multiply it by a weight. So as you can see here, the lines that connect each circle or neuron in this case, there is a weight associated with that connection. So what you do is just you take that input and you multiply it by the weight that is associated between the cascading neuron layers, and then you add a bias, which is whatever that bias may be, and then you get your output. So as you can see here, there's a simple neural network here where you have 3 layers. So the green neurons is the output layer, and the yellow neurons are the hidden layers, and the blue neurons, as you can see here, are the input layers. So activation functions. So activation functions are because as you can actually think of a neural network as simply a linear regression, advanced linear regression for multi-dimensional data. Now that might be like a little hard to understand, but overall what you can do is like, as you can see here, I'm actually doing this computation here on the top right, but doing that for multiple types of for different data, for different amounts of data, and you do that continuously for each transfer of data into the different layers. So you have to do that continuously, and whatever amount that is applied, it's probably a great amount that you have to do those concepts or applications overall. So that's why deep learning is really great for higher dimensional data, because it can do these computations linearly overall and still come out with a really good, accurate, and low loss result. So activation functions. So activation functions is essentially what provides these neural networks nonlinearity. So what I mean by that is that when you actually just give data from a deep learning for a neural network, it outputs a linear output. So it essentially does a linear function essentially for all the neurons, and it transfers from each layer overall from each different neuron, as you can see here. And then the activation function provides nonlinearity because in the sense where you want to provide a value that doesn't behave like a doesn't behave linearly. It behaves differently. It behaves like in the sense where you have higher dimensional data that you want to categorize over different types. So instead of using linear data, where obviously it's positive when it's positive and negative when it's negative, you want to do when it's negative, sometimes it has to be positive, and etc. So activation function essentially provides these neural networks with nonlinearity. Okay, so loss function. So loss function is essentially it pretty much gives feedback. It's essentially the feedback of the neural network, the deep learning neural network. And what it does is that when you get an output from your neural network, it provides a probability of how confident it is when giving it that value. So let's say that the value of the actual output that you want is 5, and from the neural network it is 95% that that value is 5. So it's very high. So it's very confident that that value is 5. So what it does is that it takes the probability, that 0.95, plugs that into a logarithmic function and multiplies that by 1 to determine the loss function. So as you can see here, it's pretty much a relationship between two probability distribution functions overall, and compares them, and the closer they are, the lower it is, like I said before. So the more similar they are, the more identical they are, the lower the loss is, until you essentially get a perfect loss, which is 0, which is kind of impossible overall. So gradient descent. So gradient descent applies to the loss function mainly because what it does is it's type of where it kind of, when you do a loss function, it actually the loss function is actually manipulated mainly by a variable of the weights, which is what you can see here early in the top right, weights. So from there you adjust the weights with gradient descent algorithm, and what it does is it tries to perfect the loss, or it tries to lower the loss every time it learns from the data. So overall, gradient descent algorithm is essentially the type of algorithm that these neural networks use so that they can lower the loss and have a higher accuracy for the output. So backpropagation is actually what moves the weights overall when learning. So backpropagation is actually the technique that is done when applying it to the weights, so that when you're changing the weights overall and you're trying to lower the loss, it essentially does that. It's essentially the technique that tries to find the optimal weight values so that you can get the perfect, or you can get it to the output that you want it to be. So those are the deep learning concepts. I'll explain that soon with a deep learning example. So as you can see here, this is the architecture of a neural network. Like I see here, each individual circle has a neuron. Each individual circle represents a neuron, and from there you give it input, and then from each neuron it has a connection with the cascading convolution or layers, neural network layers called hidden layers. And essentially what it does is it has its own associated bias and weight when doing computations between all the input neurons, and then from there it transfers in from each convolutional layer to the next, till finally you get the output that you get. Okay, so deep learning library tools. So there's different types of library tools. There's TensorFlow, which is very powerful. It's a Google created deep learning library that is applied. Keras, it's also a great deep learning tool where you're able to create deep learning neural networks easy. PyTorch, I don't really use PyTorch that much, but I know that it's also a very important or very good deep learning library in Cafe as well. So the deep learning steps. So typical training procedure for a neural network is as follows. So you define the neural network that has some learnable parameters or weights. You iterate over a data set of inputs. You process the input through the network, and you compute the loss, how far is the output from being correct, and propagate gradients back into the network's parameters. After that, you update the weights of the network, typically using a simple update rule if the weight is equal to the weight minus the learner rate times the gradient. So this is mainly what the artificial neural network does overall to lower the loss and get so that it's able to predict on the values that you wanted it to predict. So these are the certain steps that it goes through. And then we're going to go through a deep learning coding demonstration. So if anyone has any questions, feel free to ask. If anyone's interested. Okay, so here we are with our deep learning demonstration. So from here, obviously in this first code block, we essentially import all the Python libraries that we need for this for the task that we wanted to do regarding the artificial neural network. So we have matplotlib.pyplot, obviously to plot the graphs, numpy, obviously for high dimensional calculations, ospil, which is um, image library, TensorFlow, deep learning library as well, and we import all the essential layers and so that we can create the artificial neural network that we want. So here we're actually doing an image classification type of image. We're applying deep learning to image classification, which is one of the upcoming tasks that deep learning is being applied to mainly. So obviously, in a sense, we're applying. So we're going to be actually using a test. We're using a test data set, which is the MNIST data set, which is a database of handwritten images available from this page, and it has a training set of 60,000 examples, a test set of 10,000, and it is a subset of a larger set available from NIST. So these digits have been size normalized and centered in a fixed size image. So an example of this is this one. So this is actually a handwritten image, and it is actually pre-processed so that makes it easier for the neural network to learn from data overall, from the image data. So here we extract the data. So the data can be imported from TensorFlow and Keras. And here we dissect the train images that they have, the train labels, the test images, test labels, etc. And then we divide it by 255, the train images and the test images. And the reason why we do that is because we want to have normalized inputs. So it actually makes it easier that when you're inputting data into your neural network, the inputs actually are between 0 and 1. So with image data, what it does is that you have RGB values that can range from 0 to 255. So what you want to do is you want to normalize the data by dividing it by 255 so that the values are between 0 and 1, so that it makes it easier for your neural network to learn from the image data overall. So obviously just applying the image data, the test image data, the train, and so what we do here is we actually expand the train images and test image dimensions. And the reason why we do need to do that is because when we apply our deep learning model, it actually can accept the actual data shape that it has. So let's say that this is I think 28 by 28 an image. This is a 28 by 28 image. So overall, we want to transfer that shape over to the right and make sure that that the shape of the data that we have for the train images is proper, so that when we input it into the model, it is able to train. So here we define our model. So what's actually very different here from what we actually provided in the actual slides is we use convolutional neural networks. So convolutional neural networks, they actually are a type of layer within Keras that you can use for mainly image classification and object localization overall. So essentially, it makes it easier for your image data to be applied, or it makes it easier for that so that you can apply image data mainly through one layer instead of actually flattening out the image into a multi-dimensional array and applying it that way. So here we have a convolutional neural network. We have a max pooling layer. Oh, to add on, so the convolutional neural network is actually a layer that's actually supposed to determine the higher level features within an image. So it's supposed to determine the different details within an image, like a face or whatever, say anything that's highlighted overall or anything that's really important in the image. And it's supposed to determine that from doing convolution over different filters. So to provide an example about this is I have a picture of so as you can see here, this is an example of what it does overall. This is what a convolutional layer does. So essentially what this light or dark green layer here is called a kernel. So it's essentially a convolutional layer, and what it does is it pretty much cascades itself across the image data, and from there it kind of determines and kind of like reduces the amount of dimensions that the image has and puts it into one block per pixel. So obviously this is an example of the convolutional layer. And the max pooling layer, essentially it takes these kernels or these dark green layers and combines them together so that it makes it easier to analyze overall over a span. So after getting your data, you want to then flatten that out so that it returns to the amount of neurons that you want to apply. So obviously in the sense here you have the max pooling layers, and then essentially with the max pooling layers, which essentially reflect feature maps, which reflect the image itself, you flatten that image out so that you get individual values overall, and you apply that to a dense layer of 64 neurons, and then you do a dropout, and then overall after you do that, you do the dense layer of 10, and then activation of softmax. So to go back to understanding that, so the output layer is actually, there's 10 neurons in the output layer, and the reason why that is because the data set that we're doing has different categories of values. So it has 10 digits, and we apply that overall, and we use the activation function softmax, which provides nonlinearity for the model overall when learning. As you can see here, we fit the data over the training images, the training labels, and we go and we iterate that 5 times, and we do it over a batch size of 64. So what epochs means is that it iterates through the data 5 times, and the batch size essentially reflects on how much data does it take before analyzing it again. So it takes 64 instances, does it again, 64 instances, does it again, and does that 5 times. The validation split reflects on how much data that it actually validates the data, so that that the data that you're correlating it with is still proper. And as you can see here, that we still have a very high accuracy. So we have 97% accuracy, 98% accuracy, and 99% accuracy with data. Then from here, we're able to plot the history of our data or our learning methods overall from the training. And we're able to see that over time, as the epochs grow on, that we have a higher model accuracy. So as you can see here, our training accuracy is actually higher than test, which is actually very good. But the closer they are, the better it is, because it just shows that there's a very good correlation and that it's able to better generalize over new data. So this is a reflection of accuracy, and then here we're a reflection of loss. So of course, as we talked about earlier, is that you have to lower the amount of loss when learning, because it's a comparison between two probability distribution functions, the one that reflects the probability or how confident the model thinks it is that value, and obviously the output that you already know. So as you can see here, as the training data, as you can see here, the loss actually gets lower than 0.03, which is a very small value, which is very good. But then with the test value, it's actually leveling around 0.04, which shows that it's decent at generalizing over new data, but overall it's very good. And then obviously in a sense where you can do predictions over different data, and you can get an output from there. So this actually provides you the data overall from new images, and essentially it just shows that with higher dimensional data and with deep learning, you can do a lot of complex calculations and a lot of complex tasks. But overall, yeah, it's a very good tool. Okay, so I think that's it. Anyone else have any questions regarding anything? Please feel free to contact either me or Kajal. Thank you for joining us at this event, and I'll stay behind if anyone has any questions regarding regarding any of these topics, and also Kajal can also may stay. But if any of you guys are interested in actually exploring this type of field, feel free to ask us after. So yeah, that's the end of it. Thank you guys for joining us.
This was a good presentation. I definitely have a question. Can you hear me?
Yeah, I can hear you. Yeah, sure.
Great. So I think this was very informative for students. The one thing, well, actually, your presentation was very concise, even though you covered a lot of topics. I will say it was pretty good. The one thing I definitely wanted to know, and maybe other students had this question, from the first example, when you were going through the housing data set and then you finally had the root mean squared error term to be, I think it was like 67,000.
Mm-hmm.
What choices could you have made to try and improve upon that error that you saw?
Uh, well, mainly overall, actually, to improve your model, it's either try to find and tune model parameters. That's an example. A model, so you kind of, for example, I don't know if you can tune the linear regression algorithm that scikit-learn has, but another thing is gathering more data. So the first option, if you want to improve your model, gather more data so that it is better at generalizing overall. And then from there, if you think you have enough data, then work on your parameters regarding the model and work from there. So that's just my personal opinion about how I've learned about machine learning so far. But mainly it's just gathering more data, and if you want to improve the model, and then adjust your parameters that way. So in the sense, yeah, that's just
Carlos,
my
I can add to it.
yeah, sure.
So yeah, the things that Carlos mentioned are very important, but if you want to improve your model performance more, what you can try out is, so there are so many variables present in while training, right? So some of the variables might be helpful, which may actually make an impact in increasing the accuracy of a model, and sometimes there might be a variable that is not doing anything else, and maybe it is even downgrading the model performance. So one thing you can try is play with a combinations of variable and to see which one is improving or boosting your model accuracy. And like Carlos introduced, you can play with their Pearson correlation and select some variables from them, or you can use a chi-square test in order to see whether you want to which categorical variables you want to keep and which you want to discard. There are also other things like linear regression is just one way of doing or solving a particular machine learning problem. There are various other models that you can play with, like there are random forests, there are decision trees, there are naive Bayes. You can play with the model also, because sometimes it happens is, and most of the times this happens in industry related problem is, one model is not able to generalize or work well for that particular data. So in order to have as much performance as you can for your particular problem, it is better to change the model and see which one works best for you.
Yeah, okay, good. Thank you.
So if anyone else has
I
any other questions?
Yeah, I kind of want to piggyback from that. Like, how do you know your model is good? I guess, like, do you go by the accuracy and
Oh,
if it's
okay. So
overfitting or overbiased?
so regression is actually really different because you can't really say you can't really apply overfitting or anything in regarding to that because mainly it's just simply just regression. So overall, so if you want to talk about classification, yeah, when you do a classification model, you might have overfitting, but with regression, overall, it's interesting to say because overall, when you do linear regression, it tries its best because the loss function that you're applying, it's actually not meant overall to understand overfitting. It's actually understand the disparity of how well your linear function applies to that set of data. So it's really hard to say, in my opinion, in the sense where I can't really say that you can apply overfitting, but you can just say that because the metric is different for regression. The metric is different. If you're doing classification, it's very different. But regarding regression, regarding that, it's mainly just utilizing the loss functions that you have, like root mean square error or mean absolute error, which I didn't go over in my present or over my example. But mainly, it mainly depends on the task that you're trying to do, regression or classification overall.
And a small addition to that, so there is also one way to see how your model is actually performing. So there are two data sets, right? One is training data set and one is test data set. So sometimes it is possible that training set data set doesn't contain all the information which is required for a model to learn. So the best way to analyze whether a model is working perfect or not is running it over multiple of test data set to see and evaluate how is the model's performance on something which the model has never seen. So by continuing between training and testing, yeah, Connor, thanks. Cross validation is the term. So while
Yeah.
continuing between these things, you can actually test how your model is performing.
Thank you.
Okay. So another thing I like to add. So I know that data science mainly is kind of mainly pertaining to like the computer science and the mathematics field, but overall, I like to demonstrate that machine learning is joining in the engineering field as well. So in the sense where learning machine learning is actually a great asset because nowadays companies, hardware companies like NVIDIA, AMD are actually utilizing machine learning in their manufacturing processes. So knowing machine learning overall and applying that to different fields would be a great thing regardless of what background you have. So as an electrical engineering major, obviously in the sense at first when learning about it overall, it was a little intimidating because I found out that was mainly regarding CS and mainly statistics, but just having the opportunity with working with Professor Krisha in research kind of just gave me an outlook that machine learning is moving along to different industries and being applied in different industries. So yeah. Anyone else have any questions?
I have a question.
Mm-hmm.
So I've been actually looking up. I've been searching for an answer, but maybe someone here will have an answer for me. Do you guys have any tips on training sparse neural networks instead of dense neural networks? Because I've been struggling.
I haven't really done work with sparse neural networks. If Kajal or Connor have
Yes,
anything.
yes. So actually, I once worked on sparse neural network, and during that time, I was working on TensorFlow 1 point something, and it actually didn't have the configuration for handling sparse vectors. But now TensorFlow, I think TensorFlow is pretty up to date now, and it is able to work on sparse vectors, and maybe you can try and check the exposed ABI for TensorFlow.
Okay, so it would be included in like their libraries right now, I guess.
Yeah, yeah. So actually, how this power spectrum work is, so it's helpful in data model compression. So you know that the deep learning model are very huge, and suppose we want to wrap a 500 MB model in a mobile, that won't be possible. So in that case, we will do a selection of neurons which are actually contributing in our prediction. And in that, for that use case, what we will do is we will pick all those neurons, we'll bundle it into a model, and that is a sparse model. And earlier there was not a feature where you could decode this model and perform sparse matrix multiplication on it. But I think right now TensorFlow community has exposed it, or even if it is not exposed, then you can find it in some of their issues, and you can fork that thing out and you can run it. It will be much better than the dense model.
Okay, I'll definitely check it out. Thank you.
Anyone else have a question?
Actually, I have another question. I've been trying to send an email to you, the club, but it's saying that the email's been blocked.
Oh, which club are you trying to send an email?
The data science.
Data science. Okay, so that won't be an issue. I don't know why you are facing that problem, but please send an email to me, and we can connect over there. I'm just typing out my email in the chat window.
Okay, thank you.
In addition, we also did this event to appeal to undergrads, because I don't know if any of you, most of you know that the Data Science Club is a graduate club, so it's mainly for graduate students. But I was actually we kind of mainly did this event so that we can kind of get data science and machine learning exposed to the undergraduate students because we know that a lot of undergrads are really interested about this topic overall. But so we plan on doing these types of events more in the future. But yeah.
I have another question on, like, I guess, do you guys have any tips or advice on how to work with large data sets And by large, I mean like maybe like a million rows, a couple of hundred columns.
For me personally, I would have to say if you want to work with a lot of data, you're gonna need pretty decent hardware to handle it. So that's just from because I built my computer regarding around machine learning research. So I was mainly doing research in the beginning with my laptop, and it wasn't as powerful. So in the sense where I recommend first overall when I started doing machine learning work, it was mainly with my laptop, I said, but then when I kind of created a new computer and updated my hardware and etc like that, I was able to handle that data more better because when in accordance with in relation to just using my laptop. So in the sense where if you want to manage higher or like a lot of data, like a million rows, you said, or a million data instances, consider thinking about if you need to actually upgrade your hardware first, or you can use any other app platforms. I know Google has Collab. Amazon Web Services also has applications for deep learning, and you can use their inboard applications for that. But if you want to do it on your own, or you want to do it without doing it simply just through programming, then I just recommend that get a good CPU and do applications that way. That's just my opinion.
I'm going to tackle onto that really quickly because I was speaking about this in class a few weeks ago. Oftentimes, I think buying hardware locally for your own PC can be very expensive. So, Amazon
Yeah.
Web Services, like you mentioned, and also Microsoft Azure, I think Google as well, they have like a promotion where if you sign up as a student, you get access to some limited amount of cloud computing resources. So they take care of all the hardware for you. You basically just rent your usage. And then from a software and like coding perspective, I'm going to suggest for you Spark or PySpark because it's a library that's optimized for using data sets that are very large in terms of number of observations. Like you said, greater than 1 million rows. So learning PySpark or Spark in a cloud environment would definitely help you out there.
Thank you.
Hi, I have a question. You're talking about hardware. What about sources of data that we can experiment with, or
TensorFlow and Keras. So Keras is actually not. It's mainly you have to have it run with a backend. So what I mean by backend is that you need backend libraries like either TensorFlow or Theano to operate Keras. So mainly, if you use TensorFlow and Keras, utilize both libraries. They do come with data sets, like I said before. They come with image data sets like Scifar 10, MNIST, or Scifar 100. You can also go on Kaggle. That's also a great source of data sets. So people can share their different data sets and etc. Obviously, Google, Microsoft have their own data sets. So data sets are already out there. A lot of universities, I think UC Irvine has their own machine learning data sets as well, and they provide them out into public. So yeah, there's a lot of examples that you can find and apply them. It's really about understanding the data and applying from there. But overall, the biggest challenge with machine learning and data science is gathering the data. That is the biggest challenge. You could kind of say that applying the algorithms and testing the parameters is kind of the easiest part. The hardest part is data acquisition and analysis. So in the sense where, that's why these companies pay a lot of money for data science analytics. Because, it's very difficult to gather the data, but now that they invest a lot of money into it, it's easier for them to gain insights and kind of get ahead from the competition. But that's just from what I know overall. If anyone
thank you.
wants to add in. Also, I'd like to add, in addition to obviously applying this data, so actually nowadays, machine learning and AI are actually being applied to IoT, so which is Internet of Things. So you're applying that to hardware boards, obviously not big big pay grade computers overall, but you're applying that to different devices like small hardware boards where you're able to, like Raspberry Pi, for example. So, and a lot of like engineering industries, etc., are utilizing the TensorFlow and deep learning libraries to do these types of tasks. So overall, in the sense where, yeah, you're gathering the data is a great thing and understanding, but actually, and applying that even more in a hardware perspective is actually is really interesting now, because obviously it can be applied to robotics, it can be pretty much AI and machine learning and data science can be applied to pretty much any field. It just pretty much is up to you which field do you think you would like to apply it in, and then you learn from there, you gain your general knowledge, and you progress from there. Yeah, that's my take on it. Does anyone else have any questions? Anyone else? So
I would like to ask one last question, I promise.
no, that's fine, man. That's fine.
I mean, I already have a job, so like I started learning data science. This is not a technical question; it's more like a soft skill type of question. But how do you, in general, how do you guys, I guess, deal with like a manager, supervisor, who is very like not convinced about like data science?
Okay. I have an actual experience from this because I was talking to like a financial company or investment company for your local university in Jersey, and I was talking to them about using machine learning and AI. And the reason that they have a problem with using machine learning and data science overall, or machine learning specifically, is because it's pretty much you're pretty much inputting the data into a black box, and especially with deep learning, so you're inputting the data into a black box. And what that means is that when you put the data in there, you don't understand whether you're not seeing every computation that's being analyzed. So, in the sense where some people aren't convinced because it has that black box concept where you input data and it learns on its own and it gains experience on its own and improves on its own. But overall, it depends on the industry. In banking, yes, you need to apply it. In engineering, yeah, you need to apply it. But in the sense where it depends on what type of industry mainly and what specific task do you want to do. Because what I was mainly talking about when I was doing an interview is they wanted to do an investment like analyzing a task, so that in the sense where when they would invest money and they would invest money into different funds across the United States, and then from there they would find out about how well their fund progressed or increased or decreased in worth, and from there in the sense where they analyze about was it a good outcome, was it a bad outcome, and make analysis from there. But what they don't like about machine learning overall is that the way that you get to the output is not as clear. So in the sense where they would like to do it on hand, that's their personal preference. But in the sense, many of the industry is transitioning, so it's really up to what tasks you're applying and what industry you're applying it to. So it really depends. It really, really depends. Anyone else have any questions? Don't be shy. Don't be shy. I'm not really, I don't bug. Anyone else?
I had another question I asked earlier. I forget who it was, but I asked, how much data do you need for machine learning? And the response was huge, which I understand. You mentioned Internet of Things before, and with people using a lot of wearables and having different devices in their household, is it possible to, just kind of looking at a household or a group of households or a community, is it possible to extract enough data for machine learning to be useful on those cases where it's kind of looking more at a household, a
100%.
family, or families? Okay.
100%. And the perfect example of this is the application of federated learning. So what I'm doing in my research is called federated learning. And what federated learning means is that you get data from multiple local models. So like in the sense where, let me provide a scenario. Let's say you have a hospital. You have 3 different hospitals, right? And you have them train on data to understand the patterns with people that might have, let's say, a tumor. So you're given all the numerical attributes, and you're trying to determine, does this person have a tumor or not? And from there, and you train on your local data. So then from there, from the local data, you can actually transfer the weights and average them out into another local model, or essentially a global model, which actually averages all the weights from each individual local model that's training on their own local data set, and do a local and create the model from there. So in a sense where you can gain insights without even actually using data, which is what's so great about federated learning. Like overall, like in the sense where obviously it can be applied to the medical field, but any other field that gets data from local different sources can use federated learning. And that's why federated learning is such a powerful tool, because in the sense where you can get a great generalizing model without even looking at the local data that's being involved. So in the sense, to answer your question, yes, you can, and it's developing, and I'm working on that overall.
Thanks. Any primers or white papers on federated learning?
Well, actually, yeah, I can send you some papers. You just have to. I can send you some papers on federated learning if you're interested, but you just have to let me know about that. I'll just put my email in chat if anyone wants to talk to me after this presentation. But yeah, if anyone's interested beyond that.
Thank you.
Okay. So, anyone else have any questions? This is a very interesting field too, so don't be shy, because this field's growing and growing, and the more questions we ask about this field, the more we can progress it. So. Evan, are you saying something? Because I can't hear you. Oh, sorry. Oh.
Can you hear me now?
Yes, I can hear you now. Nice. Okay, great.
Sorry. Yeah. All right.
I couldn't hear you there.
Yeah. When you were talking about, I guess that interview with the financial that company.
It was Princeton, actually. It was Princeton. I didn't get the job, just letting you know that, but it was Princeton. So Princeton's actually, they do investment analysis and etc. But
yeah. I feel like, because I'm new to data science in general, but I do have a little bit of experience in actuarial science. That was my previous area of study. I feel like with data science, there's a difficulty in explaining how it can make an impact within a company, and I feel like it has to do with the inability or the lack of ability to articulate how the data can be used to accelerate the business model and the business logic behind it. When you're looking for companies to work for, at what stage should a data scientist, when their data model, like if they're building data warehouses and stuff, should a data scientist look in that direction, or should they wait until the company actually has the processes in place to analyze actual data? What's your feeling?
So data science, if you're a data scientist right now, the direction that you should be going in is to the big companies. And obviously, if you're like a medium, small company with like 100 to 200 employees, you won't have the processes that you will need to obviously do your data science job well. So yes, I understand that. Regarding that, you should look in the direction of big companies, and that's because mainly big companies, or like companies that have a stable structure, that have been around for a while, and that are using data science now, specifically in banking. So Morgan Stanley is doing it, Credit Suisse is doing it. Obviously, companies like investment companies, small investment companies like the Princeton Investment Company, they're small. They don't have a lot of employees. They don't really deal with stocks or anything like that in a sense. But mainly the big companies are applying data science, and they're paying very handsomely for it. So in the sense where I think that's the direction that most data science should be looking for. Because in the sense where data science overall it's mainly gathering of big data, and from that you can be able to express your ability overall.
Actually, sorry, Carlos.
No, that's fine. That's fine. You can go.
So I have a very different opinion on this. So actually, I started in data science when I was working in a startup. So everything like data science, machine learning, deep learning, computer vision, everything started from there. Because I have seen this even in a big companies. You generally people who are starting in data science, either they are undergrad or grad, until and unless they have a PhD, they are not allowed to work on that particular problem. Because in big companies like in Adobe, I actually worked in Adobe for 2 years. So I wasn't allowed for my first year to work on a machine learning problem just because I didn't have a PhD. But in my second year, since I had done so much of my work in startup, from cleaning data set to preparing models to training to deploying, I was actually given an opportunity to work on the data science actual problem. So I will say that if a person who is starting out should definitely try working in a startup, because there he will be the owner of that particular project. He will be responsible for training, collecting data, cleaning the data, analyzing data, training various models, and presenting the statistic and convincing the CEO and the founder of that startup that, okay, this is going to work, this is not going to work. And that is very crucial in data science, because until and unless you don't know the nitty gritty of data science, it is very hard, because there are so many people out there. Everyone is doing tutorials, everyone is doing a coursework and saying that, okay, I have the certificate, but where and how do you stand out? So I think that makes the difference.
Can I offer the middle ground opinion?
Yes.
Yes.
Yeah, fire away.
The reason why I say middle ground is because like I agree with both Carlos and Kajal from the extent that like tech companies, like the larger companies, oftentimes they are like, yes, they do have the infrastructure already in place, so it makes some processes a lot easier. Startups also, like on the other hand, you know, they often like they need someone to set up those infrastructure things oftentimes, or they need someone who's experienced in cloud computing. Maybe you know how to work with Azure or AWS. The reason why I'm saying I'm in the middle is because there can even be positions at larger companies where you're in charge of a large project, or you're a part of a team that's in charge of a large project. And if like whichever direction you choose, of course, that's up to you. But one thing that you may want to look into, because I can speak from experience, like where I'm working right now, some banks like UBS, I think Morgan Stanley, Goldman Sachs, they have new graduate employment programs. I think this even exists in tech companies like Facebook as well, where they group you together and like they know that you're sort of a new graduate and you're new to employment, um, but they'll still let you be a part of a larger project, and like you can work on a large part of the stack just as long as you can sort of like back up your skills, so to speak. So yes, it definitely that kind of experience exists in startups, but it does even exist in it does exist in bigger companies as well.
It boils down to just one thing: just get your fundamentals strong in data science. That's
Yeah,
it.
exactly.
Anyone else have any questions? Ask either me, Connor, or Kajal.
Thank you for
Yeah.
the presentation. It was good.
Yeah, thank you for your feedback. So I was just wondering, so for the rest of you that are still here, would you like to have this event or similar events be continued? I just want to get your input. If you can either say it or put it in chat, that'd be great. Because overall, like, just like to get some input from all of you guys to understand if you like these events and if you think these events are helpful. But if not, obviously you can tell me that as well.
I think more events like this would be good. I think the timing. There's some people don't think about timing, but I think the timing was good. It's it's there's like enough time for people that have like 4 to 5:30 class, they can come after 5:30, and then if you have 6 to 9, you can come before your 6 o'clock. So I think it's a good timing as well.
I mean in the future. I mean in the future.
Yeah, no,
Okay.
I agree. But I'm
Oh,
saying like even the
okay.
timing as well is good for the future. Yeah.
Oh, okay. Sorry. I always thought you were talking about the actual time.
No, you're good. You're good.
Anyone? Anyone have any questions? We'll be here all night.
I think we have. I think no one has questions, and I think we are running out of time. So we are 15 minutes past the time, so
yeah.
I think we can conclude it.
I'm gonna stay in here till 6:50. If anyone still wants to talk, or Connor, if anyone, it's up to you guys. But I'll be here till 6:50. Okay. So yeah, thanks, Kajal. Thanks for helping. Thanks for collaborating with IEEE.
No problem at all. Anytime. Hello.
Yeah.
Bye-bye.
Okay.
So George, I wouldn't be able to give you 100% opinion simply because I'm not involved with either organization. But I'd like to imagine, Carlos. I think I saw that you were recording it, so
yes, I was
presume
recording it.
It'll be available somewhere.
It should. I will 100% be able to provide it. It should be on the IEEE website or YouTube channel. So you can look at that. So yeah, I did record it. And if anyone missed any information, they can go back and look at the recording.
Thanks. What's the address of the YouTube channel?
Just look up NGIT IEEE on YouTube. Should be the first channel that you see in the pop-up. IEEE NGIT YouTube channel. Right. Okay. Gavin, George, Ron. Do you have any questions? Any more questions? Or feel free to leave.
Are you planning to give the same presentation at different events, like for different audiences?
So, I was talking to Kajal about this. I was talking to her about, I would like to do this same event again, because I know that some people missed out on it. But in the sense where we would have to discuss it, well, I'll have to discuss it with Kajal, and obviously if you would like to join the discussion as well, because I know that you're in the Data Science Club Slack, so, since we can meet up together and talk to Kajal about organizing a different event or organizing the same event. It really doesn't matter.
Here's a little bit of trivia, Kajal. I don't know if Kajal told you. So I helped create the club in a past life.
Nice.
But the reason why I was asking is because I thought the presentation, like others mentioned, was very concise and very well thought out. I think the only opinion I would suggest personally would be to maybe take another look again at the deep learning section, simply because there were a few elements which potentially were skipped over, or maybe could be skipped over. There, the discussion on neural networks and simple neural networks, rather, fully connected networks, I think was great, but then you started mentioning CNNs without the lead into, right? It was kind of a dive over the deep end into CNNs during the coding. So probably some people were like, wait a minute, what's this now?
Connor, so actually, if you actually saw Kajal's demonstration, it is 10 times longer than that, and it's crazy. I saw the demonstration. They use convolutional neural networks in their presentation, and they go into specific detail about it, like very specific
okay.
detail. So I told Kajal like at 2:30 or 3 o'clock. I told her, "Hey, the demonstration's it's too complex. Like, I think
Right.
if we give it to them, I think they don't understand it."
Right.
So what I ended up telling us is like, I'll do it myself. I'll create the code, not that
Okay.
difficult. But yeah, you're right. I'll definitely do that for next time. Thank you
Yeah,
for
just
telling
a
me
little.
that.
There's a little bit of a balance though.
Sorry, yeah,
No.
yeah,
You're good. You're good. You're
yeah,
good.
yeah. Thanks for the feedback.
Was this the first time you ever gave the presentation?
Yes,
Ah, okay.
yes, it is.
Okay, it's good.
I didn't
That's
even
good.
give
It's
it a
good.
run through. It was
I
kind of
see.
funny.
I see. I see.
But yeah,
Still good. Still good.
yeah.
I think even I managed to learn a thing or two. Not gonna lie.
Yeah.
The scatter matrix I did in Matplotlib I wasn't aware of.
Oh, really? Okay. Yeah.
So I think
So
that's a very helpful visualization.
yeah. Also, I could recommend some books. Actually, yeah. Connor, regarding machine learning, like there's some books that you can recommend to your class. So there's this one that's published by O'Reilly. I
Oh,
think
I love O'Reilly. Yeah,
so
for
it
sure.
you might have heard of the hands-on machine learning with scikit-learning keras and TensorFlow.
Yes,
So yeah,
yes,
I
yes.
recommend that book. I also recommend another book too. It's called Data Science and Machine Learning: Mathematical and Statistical Methods. I don't know who
That
that's.
one I didn't hear of.
It's a very good one because it actually, before it gets into the machine learning, it actually explains the math of machine learning, which is great. So I think before doing the O'Reilly hands-on, I think doing understanding the math behind it would be a great thing. But it's kind of funny because, like, in the sense, looking back, like, since I'm an electrical engineer, I like machine learning a lot. I like AI a lot. But overall, in the sense where, because like it's mainly pertaining to like mainly CS, because it's
Hmm.
really it's underneath the CS department, data science
Right.
essentially. So I
Hmm.
kind of feel like overall, just to prove the point that engineering can apply it as well.
Yeah, I think the beauty about data science, which I think you were mentioning a little bit before, and even in the questions, is that it's sort of a topic similar to CS in the sense that every industry can benefit from it in one way or another. It's just how do you communicate what you've learned in such a way that it can be convincing enough for people to actually try and tackle,
Mm.
you know.
Also, another thing is like, I don't like, to be honest. I don't like that the club is only strictly to graduate students. That's just my personal opinion. Because like, I think you would get a bigger like audience with undergrads. Because like that's just my opinion regarding it.
Yeah. No, for sure. I understand where you're coming from there. So I, again, I think the club is still a little bit new. So, from my perspective, like a year and a half ago when I was still involved, being able to tackle both audiences was just a little bit too much to bite.
Mm-hmm.
So, like I know IEEE, for example, like one strategy that you have is that you have an undergraduate chapter and you also separately have a graduate chapter, right?
Yes. Yes.
So I think that's something that they could very easily try to pursue,
Mm-hmm.
assuming that that's, within their planning for like the next year or so.
Do you think we can like talk to Kajal about that? Because like I was thinking about that idea as well. Because I think I think that it kind of limits the possibilities and the avenues of where you can apply the data science and expose it overall.
Yeah. I'll shoot her a text about it, and I'll say that we were discussing it in the after hours,
That'd be great because
the
because
after
I would
time.
like to join the club. I'd like to join the undergrad club if they ever make
What
one.
what year are you?
I'm a junior, but
Junior. Okay.
I got one more year. But I mean, if they can get something going, I would be happy to do that. But
Something I didn't really understand in my perspective as an undergrad. I didn't see it until I was a graduate student. Is that there's just not enough interaction between undergrads and grad students to begin with,
yeah.
to even realize that a club exists with GSA. So I think being able to have more organizations like IEEE. I think Wix is also divided between, or combined rather, graduate and undergraduate. Having more organizations like that.
Oh yeah, yeah.
Yes, there's rules and GSA and Senate funding and politics around all that, but just from like a student's perspective, I think it would be beneficial.
Mm, yeah. Yeah, I think Kajal sent me like some statistics regarding this. I think let's see, 95% said that it was helpful to you. This event was helpful.
But what's the sample size?
20 responses.
Okay.
That's pretty decent. That's pretty decent, I have to say.
I mean, look, it's not in the context of stats. It's
That's
not a
not great.
significant sample
That's not
size.
great.
However, we clocked in at 44, so we're just under 50%. Still decent, I think.
Yeah.
Still not good enough responses, right? But
Yeah,
decent.
I did not know that she was actually doing a poll on this.
Mm-hmm.
Like, she did not tell me she was doing a poll, but because if she told me there was a poll, I would have probably spread that out a little bit more.
I saw she sent it out in the chat in the middle of the presentation, so I don't know.
Oh,
There was
okay.
only like three. It was like a 3-question thing, so I don't know when she prepared it.
So, Connor, do you know about federated learning? I was just curious about, have you learned about or
I will tell you the truth. You are the first time I've heard of it.
Really? Okay. Interesting. So yeah,
It's not something that they go over in the master's degree, or at least it's not something that they went over when I was taking classes for the master's degree.
Okay. So actually, so regarding federated learning, I'm actually learning about how to backdoor federated learning. So I'm actually trying to create, small threats within that machine learning technique. So that's actually my research, actually, to create backdoors.
Cool.
And yeah, like it's you can really mess up some of these artificial neural networks. You can really mess them up. And it's just it's crazy to think that there are some really interesting techniques now.
Wait, is federated learning another word for adversarial attacks?
No, adversarial attacks
It's
are
different.
adversarial attacks are mainly within the field of image classification. So adversarial perturbations is what is pretty much an adversarial example. So what you do is that when you take an image, right, for image classification for a neural network, you actually add like a small value to each like individual values within the image array in the same direction as the gradient, so that it increases the loss. So that when you input the image data, it should increase the loss value when doing that image data. So that's one way of. So I'm studying that, and it's really interesting. But that's mainly applied to image classification, object detection, and that's what I'm really kind of in it for machine learning, mainly for object detection and image classification, because I think it's so cool. You know what I mean? Like imagine you just like you walk around and you have like a device and it's able to do machine learning, like facial recognition, etc.
Yeah, for sure. I think I'm not sure your direction in your career if you're trying to stay in academics or if you want to go into industry, but I think that that's a good project to slap on your CV. I think many people will find it impressive.
Yeah, actually, I'm trying to. I have a project in mind that I plan on doing for senior project for ECE. So I have a senior project in mind.
That's right. That's right. You have a senior project as well. That's right.
Yeah, so I'm planning on doing something along the lines of machine learning and deep learning, along the lines of that. It's gonna be great.
Oh, nice. Good luck.
Thank you. And yeah, but all right. Do you guys have any actual questions or because anyone have actual questions? George, Ron, Gavin, anyone?
Can you hear me?
Yeah, I can hear you. No, George, you muted yourself.
Can you hear me?
Yeah, I can hear you.
Yeah, I was gonna bring up with the image learning. There's something similar to it. The Pi. It's called a Jetson, and it's a
Jetson Nano, right? NVIDIA Jetson Nano.
Bring it up, yeah.
Exactly. Yeah, I actually before working for Professor Abdallah Shah in ECE department, I worked with Professor Wang, and he was doing something along the lines with machine learning, because he wanted to teach a car how to drive on its own. Like that's what like the actual study is. He actually is trying to understand autonomous behavior without actually, you know what I mean, without any supervised input or without any input. So it's actually supposed to so in the sense where what the project entails is that you have like a car and you have a program with like an autonomous system with a hardware board, and what it does is that it observes like other autonomous system or other like vehicle systems that are within its vicinity and how they behave in accordance with let's see how it reacts with certain signals. So like obviously with a red light, it would stop. So next time it would have to learn that when it sees a red light, it would have to stop on its own. So I worked in that research lab for a year and a half up until COVID happened. So I'm not in that lab anymore. So now I'm working with Professor Grishaw, and mainly, yeah, that's when I realized that AI and machine learning can really be applied into hardware and engineering itself, and specifically like automation engineering and vehicles and etc. But it's kind of almost endless. But yeah, the Jetson.
Did you use the Jetson Nano specifically, or
what'd you say?
did you get did you use the hands-on with the Jetson Nano?
So I did not use the Nano personally. I used the National Instruments Mario board. And the Jetson Nano, a graduate student was working on the Jetson Nano, and he was able to do facial detection with it, and it was very nice. It was very cool, because NVIDIA, the Nano is a great piece of hardware overall for even for what it's cost. It's great. It can do a lot of computations, and it can do everything mainly around AI, which is great. And obviously, I plan on like searching and utilizing some hardware boards to do the same thing overall. But yeah, it's a very good board. I've seen it in action. But I mainly in my personal research I used the National Instruments Mario board, and with National Instruments they actually come provided with a machine vision library, so you can do it that way. But depends on what board. You can go to National Instruments, you can go to NVIDIA. They all have these. Or Intel actually had the compute stick, or I think the Intel had the 570X, which was actually good up to a point until they stopped developing it, which was such a pity because they actually made the Intel 570X module for computer vision, and obviously in the sense where it was very powerful to do some facial, obviously object localization and image classification from there. But sadly, they stopped focusing on that, and they went on to other projects. But overall, yeah, it's moving to the hardware game. It's mainly about utilizing it with hardware now in engineering, regarding engineering more than ever. But strictly just with just data, then yeah, cloud computing, etc.
Can I ask an unrelated question? It's I got the certificate in the data mining. And, how does the school work with? I know there's rules if your classes are over 8 years old since when you originally took them, they become inactive. Do you have any experience or know anyone who had to apply to get them reactivated to get your credits in order to? Because this was 10 years ago.
I'm still an undergrad, man. I'm sorry.
Yeah.
Connor, you have anything to add on that?
I've been involved with the university for 6.5 years, and I don't even know anybody. But I used to work for the orientation program, and we used to delegate different advice for questions like this. My best advice would just be to straight up just ask registrar. It might be like a pain in the neck to get a hold of them, considering it's an online environment, but at the end of the day, they're going to give you the straight answer. So I would well, registrar, and also admissions, and also are you a graduate student, or would you be a graduate student, or applying it as an undergraduate student?
I'm currently a graduate student. I'll tell you where I'm at right now. Thanks for. I know this isn't on a general topic, but I've gone to my counselor and they sent me to it's computer science. I spoke to the not a secretary, but the main person in contact. He put me in reach with administrator, and it's been a 2-week wait. And I kind of feel I'm being put in the wrong direction because at first she didn't know, but that's kind of where I'm at right now.
Yeah,
I think he should talk to who's that CS advisor. I forgot what her name was.
See, the thing is, even the advisors aren't really the best POC for this.
Maybe, yeah.
The advisors are really good at delegating your class. Well, actually, maybe.
Maybe. I think Actually I was actually gonna plan on asking you this question because I'm planning. Do you think it's because as an electrical engineering major, do you think it's worth it to get a master's in data science at where I am now?
I'm gonna answer that question, but I'm also gonna tell George to hang on a second because I'm looking for some emails
Oh, that's fine.
that for like a person of contact that may be able to help you. So just give me a minute. And then Carlos, for your question, I would. It's a hard question, like in terms of answering yes versus no. But one benefit that I can say is that at the end of the day, generally speaking, a higher school degree usually correlates with a higher starting salary. So if that's something that you're interested in, I would weigh that very strongly, and also consider like the BSMS program, because that means at NJIT you would be able to finish your program theoretically in uh, just a year for your graduate degree because you start taking some as an undergrad. So that's another thing that I would say to weigh very strongly.
I'm not in the CS department though. I'm electrical engineering.
I would go try to talk to the CS advisors. You can kind of backdoor that.
Really?
I think.
Okay.
Take that with a grain of salt.
I'm gonna take it with a grain of salt. I understand.
Exactly. So okay. George, can you tell me particularly names of people you spoke to? I hate to put you on the spot like that, but
the advisor I spoke with was Pledger or King Pledger.
Oh, Darnell. Yeah. Okay.
Yeah, he seemed kind of new.
He is. He's only a year. He's only a year in.
Yeah.
I remember. He was my advisor last year when I was a student. So it can be tough with new advisors. But who was he? The first person you spoke to?
He was. Yeah.
Who else have you spoken to? Anybody?
I spoke to in the computer science department. Is it the secretary or the office administrator? And I'm on a 2-week hold, waiting to have my email applied to before. Not even replied to because at first she said I was going in the wrong direction. She said that my advisor should know. My advisor said she should know. So I'm kind of going back and forth.
Okay.
I'm curious to know, is there like a main advisor that advises the advisors I can go to? Or a supervisor of an advisor?
That's a funny question, which is outside of my field of view. I will suggest for you though, questions like this are often should be delegated to like the people that are just in charge of graduate degrees in general. So I'm gonna say like, because this is for your graduate degree, right? You mentioned.
Yeah.
Okay. Try to speak to the Office of Graduate Studies, and in particular, someone who was very good with knowledge and helping me out was so I'll type the name. Brian. I'm not even going to try to pronounce his last name because I'll probably butcher it. So this is the assistant director for graduate programs in Office of Graduate Studies. I think, generally speaking, anybody in that office would probably be able to more or less answer your question. But Brian in particular, he was helping me with like, without getting too specific, technicalities with grad degrees.
Okay.
So I think he may be able to help you. And if not, he may be. I know you're getting bounced back and forth here, but that's very common at NJIT. You may get bounced again.
I got to stop getting bounced. I'm supposed to graduate this semester, so that's too much. I hope I don't get bounced too much.
Hopefully not.
Thanks, though. Appreciate it.
Yeah.
Anyone else? Honestly, Ron, Gavin. But yeah, actually, Connor, I was actually wondering if we could, like, talk to, like, if we can collaborate, me, you, and Kajal, maybe do like a kind of like a try collaboration, because I know you're the machine learning club, right?
Or
is that data science?
So the machine learning club is the Data Science Club. That there was a name change, but the website never changed.
Oh,
I
really?
I am not a student anymore, so I this
Oh, you're a
semester
professor.
I'm teaching as an adjunct this semester, but yeah, so I'm not involved in the club directly anymore.
Okay.
During the day, I do have an industry position, so like night times would, if I do manage to come help out with an event of some sort, I think, you know, that's why I mentioned before that this timing was good, or like a weekend worst case.
Okay.
And yeah, I did send her a text about the graduate versus undergraduate thing. She hasn't. I'm sure she's doing homework or something at this point, so it'll take her some time. But I'll let her know that you know, you reached out about that, and you know, kind of collaborate with you.
Okay. Cool.
Yeah, for sure.
All right. If that's it, all right. You guys have a good day.
Oh, she just texted me back, so I'll get back to her and tell her to coordinate with you.
Okay.
Thank you, Carlos. It was a
Yep.
good event.
Um.
Ron, if you come tomorrow night, I'll talk to you tomorrow night, Ron.
Okay. All right. Okay, guys. You have a good day now.
Yep, you too.